In this video, we're going to look at constant change. What I mean by that is, what is the effect of constant change on a data set? Firstly, we're going to look at what happens if we add or subtract a constant to every member of a data set. Secondly, we're going to look at what is the effect if we multiply each member of a data set by a constant value, or divide that data set by a constant value. I want you to take a look at the data set 1, 2, 5, 5, 7. And we can work out the mean, median, mode, range, interquartile range, standard deviation, and the variance. Well, the mean for this data set is 4. The median, the middle value, as you can see, is 5. The mode is 5 because it occurs most often. The range, well, the largest value is 7. Subtract the smallest value is 1. So that gives a range of 6. The interquartile range, well, Q1 is halfway between 1 and 2, which is 1.5. Q3 is halfway between 5 and 7, so that gives us an interquartile range of 6 minus 1.5, which is 4.5. And I've worked out the standard deviation is equal to 2.19. And if I square that, I get the variance, which gives me 4.8. Firstly, I want to look at if each number is increased by a constant 3, calculate the new mean, the new median, the new mode, range, interquartile range, standard deviation, and variance. Well, the new data set would be, if I add 3 to each one, 4, 5, 8, 8, and 10. Well, if you look at the data set, everything has been moved 3 spaces to the right on the number line. So, what happens to the new mean? Well, the new mean, every data point is 3 larger, so surely that would affect the mean. It would now, each data point would be 3 larger, so the mean would be 3 larger. And if I calculate the new set of data, I get that the mean is 7. Well, that's an increase of 3. The median has now moved to 8. Well, that's an increase of 3. The mode is now 8, which is increased by 3. The new range is 10 minus 6, which is now 6. That stayed the same. The interquartile range, well, that is 9 minus 4.5, which is still 4.5. And I've calculated the new standard deviation, which stays at 2.19. And so the new variance would stay at 4.8. So, adding a constant seems to change the mean, median, and mode, well, the central tendency, because everything has moved by that same amount, either to the right on the number line, if you're adding, or it's moved to the left on the number line if you are subtracting. The second thing I want to look at is what's the effect of a multiplier on the data set. So if I multiply each member of the data set by a constant, or divide each member of the data set by a constant, what happens to the mean, median, mode, range, interquartile range, standard deviation, and variance? So, if each number is multiplied by a constant 2, calculate the new mean, median, mode, range, interquartile range, standard deviation, and variance. Well, the new data set would be 2, 4, 10, 10, and 14. So calculating the new mean would give me a value of 8. The new median would be 10. The new mode would also be 10. The new range would be 12 minus 2, which is 10. The new interquartile range would be 12 minus 3, which is 9. And the new standard deviation would be 4.38. And the new variance would be 4.38 squared, which would give me 19.2. So what has happened? Well, the mean, median, and mode have all been doubled. Well, you would expect that because each value is now twice as big. So you've got the total will be twice as big, divided by the same number of pieces of data. So the mean would be twice as big. The median, the number in the middle, would now be twice the size. The mode, the one that occurs most often, would be twice the size. The range would also be twice the size. If that's the case, the interquartile range would be twice the size. The standard deviation, they're all more spread out. Well, they're twice as spread out. So the standard deviation would be twice as big. And because the standard deviation has been multiplied by 2, because the variance is the standard deviation squared, 2 squared is 4. So that would be 4 times as big. So let's summarize what happens when you add a constant or multiply by a constant. Effect of constant changes on the original data. Adding a constant c to every value in a data set increases the mean and the median by c and has no effect on the standard deviation. Multiplying every value in a data set by a constant d means that the mean and standard deviation will also be multiplied by d, and the variance will be multiplied by d squared.